Hello, everyone. You have a good coffee break? Yummy cake and coffee. All right, here we go. Building a Bitcoin bank, or a little bit of a technical overview, very high level of the Galloy tech stack. I'm Justin Carter. Most of my career in the software industry, I've been a consultant helping enterprises operate and scale and automate everything around large-scale distributed systems, multi-cloud, multi-region installations, very big systems. I've been in the Bitcoin space since 2017 when I founded a startup, misthos. We developed a multisig wallet, optimized for collaboration, intended for like shared custody use cases. And I've just generally been committing to various open source projects in the space since then. Is the clicker going to work? Yes. Here we go. So I work for Galloy. We are the company who built the Bitcoin Beach wallet that I'll be talking about now. We build an end-to-end solution for Bitcoin banking. So it's not like you're just running your node at home where you have your LND and your Bitcoin D. Having a whole banking solution in a prepackaged way is a little bit more involved. And it's meant to be brought up by communities, by institutions or banks or enterprises. Anyone who wants to offer Bitcoin banking service to their end users, basically. And like I mentioned, the Bitcoin Beach wallet was the first, like the prototype, basically, of this. For Bitcoin Beach, we created a communal, like shared custody solution. So there's hot wallet and a cold wallet. And the cold wallet, the idea is that the custodians of the cold wallet are in the community or in the enterprise or whatever client is consuming the stack. So we don't hold or control the funds. It's all free and open source software. Of course, we build on all the open source stuff that is in the ecosystem, and our code for the entire banking stack that I'm going to talk about today is also open source. So if you're a community that you want to run a bank for your people yourself, then it's all there. That being said, it is a fairly complex system, has like a microservice architecture, and we run it on a public cloud infrastructure. It's built for Kubernetes so that we don't have any lock-in to the IaaS provider that we use. So if different clients want to run it on different clouds, then we can serve those purposes and offer, enterprise-grade features like high availability and horizontal scalability, etc. All right, so a little bit of overview of the technologies we use. In the backend services that we've written, it's all TypeScript, and our main interaction layer to the external world is via a GraphQL API that I will talk about. The front end is also in TypeScript. We use React Native to be able to have cross-platform compilations, and the backend services, we have also lots of supporting services, not just the services that we've built, Bitcoin D and LND, of course, MongoDB to persist most of our data, Redis is kind of a cache, Prometheus, Grafana, OpenTelemetry, everything you need basically to operate a distributed system is part of the stack. Other components that aren't in here too, because it has to be self-contained to have this portability between clouds. We don't want the lock-in, we want to be able to people to host it how they want, basically, and that means we need to bring in the whole operating stack as well. Right. Moving further, this is an architectural overview with not all, but most of the services that we operate. The whole thing is running in Kubernetes. It's a scheduling service that all public clouds have managed versions of. You can also run that yourself, but I wouldn't recommend it. It's very complex in itself. But anyway, it gives us the ability to give workloads, processes in the form of Docker images that we want to be run, and Kubernetes will match the processes that we want to run to compute resources that we've reserved in the form of VMs, and Kubernetes takes care of scheduling and rolling updates and stuff like that. Horizontal scalability. I'm just going to highlight a few of these before we go through some use cases. The GraphQL API is where most of our business logic lies. It's basically the most important part of the backend stack, and the place that all of the external functionality is the way that the functionality is exposed externally. We had a workshop a couple hours ago. Did anyone attend it and learn about the GraphQL API? Yeah, awesome. Great. Yeah, so moving forward, admin panel. It's another part of the stack. If you deploy it, this is for clients that are operating the bank to be able to get some information of, payments, or if something went wrong with the payment, then this is a way for the community to self-service, or whoever is the admin of the community, to get some insights without having to bother us. Galloy Pay is another website that we host in the stack. You may have used it if you've got one of our t-shirts. You just go to a website and you can input an amount that you want, and it will it'll spit out a QR code, a Bolt 11 Lightning invoice. Oh, come on. There we go. A final user or client-facing part of this stack is Spectre Wallet. For the communal custody, we have a multisig, like I mentioned it, and we're using Spectre to configure that multisig, and so that's also exposed externally. So when people want to interface with a cold wallet, they would log into Spectre to be able to do that. Right. Let's see what it looks like in action. Go through a few use cases so you can see what is happening at runtime. First example, receive a Lightning payment. This is a screenshot from our documentation. It's a GraphQL API, like I mentioned. GraphQL is very flexible and extendable and self-documenting, which is pretty cool. So in this case, we need to call the API with the ln invoice create mutation and give it inputs, Satoshi amount, and a memo that will be put into the invoice. In this example, the call will be coming from the mobile front end. First, it comes in the load balancer. What I didn't mention before, or well, I have mentioned it briefly, that there's not just one GraphQL API running, but there's like many, because for high availability, etc. So it has to go through the load balancer, and it chooses which API it's going to hit. And the business logic then calls out to the LND, oh, gonna create an invoice, all right. LND comes back with an invoice, and then we have to persist it in MongoDB. This is so that we have internally a mapping between the user that created the invoice and the invoice, so that when the payment comes in, we can associate it and credit the user correctly. There we go. Then we have this trigger component. It's a microservice that is listening to LND and gets informed when a payment has arrived. It has the details it needs to be able to go and look up in the database which invoice was paid, which user was it associated with, and we update our internal ledger so that the balance is reflected correctly. And finally, we will send a notification out via Firebase so that my phone started doing something weird. Strange. Music coming out of my pocket. Anyway, okay, so the notification will go back to the UI, and so that the user can see, oh, I got money, and that's always a nice experience. Let us keep going. Next use case, sending a Lightning payment. It's a little bit more involved. We have two calls we have to make to the API to get this to work. First is ln invoice fee probe, and the next one is ln invoice payment send. We'll start with the probe. Why do we probe first? Well, it's a UX optimization. On the one hand, by probing, we can find out, is there a path? Is there the liquidity needed to send the payment? And we can give the feedback to the user. First of all, yeah, we can make the payment. And second of all, like, what is the fee that you can expect? So again, the call comes in to the business logic. We're going to ask LND to probe for a route. And if a route was found, we can cache it in Redis and return the fee back to the UI. Then the user can confirm the payment. Yes, I want to make this payment for this fee. And first thing we do is check if the payment that we are if the invoice that we've scanned and are paying actually belongs to us, right? So this is an optimization. If we have a reference of the invoice in our database and an association with the user, that means we don't really need to settle via Lightning. We can just settle it internally, which is what we do. But to continue the use case, let's say, no, it's not one of our invoices, it's someone else's invoice. Then we go and look up the route in Redis, and now update the ledger. Not make the payment. Why update the ledger? Well, we have to make sure that we reserve the balance for the user first before we make the payment. We don't want to have a double spend. So here we're reserving the balance for the user so that when we make the payment, pay via routes, we know there's not going to be a double spend. Once the payment goes out successfully, then we update the ledger again so that the previously reserved payment is finally deducted from the user's balance. As you can see, this use case is already fairly complex, a lot more complex than just like scanning a QR code and sending it to L&D. There's more involved, and this is just part of the complexity of having a whole full banking solution. Also, I'm only talking about the happy path here, of course. Any one of these steps could fail, and we need to then potentially roll back, undo the reserved payment, and what do I know? Yeah, stuff like that. So let's keep going. Rebalancing hot and cold wallet. All right. So here's another guy in our stack, a cron job. As we receive and send payments, our hot wallet will grow and shrink, but let's say it grows. And what I didn't mention is we don't only accept Lightning payments, but we also support these use cases for on-chain payments. So eventually we might have a mismatch between how much we have in the hot wallet. So we have a configuration to say what ratio of Bitcoin do you want in the hot wallet and what ratio of Bitcoin do you want in the cold wallet. And this guy will check if that ratio is intact. And if it finds out, oh no, we need to make a rebalance, then it'll go out to L&D and say send to on-chain address. And that will basically send a transaction to an address that was derived from the multisig wallet that has been configured in Spectre. And to complete this use case, we also have to update the ledger again. So this is another detail. We have a full double-sided entry bookkeeping. I always forget that word, double-sided bookkeeping, right. And it's for consistency and auditability, and it's just for banking applications, it's the standard. And even though this is an internal transfer, it's like going from the hot wallet to the cold wallet, we have different records of account for each of the wallets, even though they're simply internal. We treat it the same way as if an end user was moving around money, just to have a proper trace of every single payment that happens, every single movement of money that happens. All right, so those were a few example use cases that are end user facing. I'm also going to talk a little bit about our rollout process and operations. Since we have designed the stack to be able to reproduce it, we want to bring up many of these, not just one, but a couple months down the road we might have a dozen deployed, right, for various clients or communities. So we have to be operationally scalable. We have to be able to manage a dozen of these production environments with limited resources. And to do this in a secure way, we're relying on automation systems, basically Concourse for the automated jobs, and GitHub for triggering the next step in the automation. And I'm going to talk about this a little bit. I always want to point that way. There we go. Oops. Yeah. Okay, so the first step, when a change gets merged to one of our backend repositories, we see a bunch of jobs get kicked off. The run the unit tests, integration tests, and finally build a Docker image. The Docker image is like the final representation of the artifact that is going to be put into production. It contains the definition of the process that's going to run. And if all that works, it creates a pull request on the charts repository. What is the charts repository? So in Kubernetes has a fair amount of complexity in itself, and it needs to be configured properly. It's not just like here's a Docker container run it, it's like, how do you want to run it? How do you want to expose it? How do you want to scale it? All this kind of stuff needs to be configured. And that is done, or what we're doing is using a tool called Helm, which provides a packaging layer which brings together the image and the config of how to run it. So once the image has been built and tested and vetted, this pull request is basically updating the reference to that image in our Helm chart and saying, okay, we're going to move to the next image. And inside of the pull request, we have a link back to a diff of the source code, because you don't necessarily know when the image was updated what code is actually inside that image, right? So developers looking at this can see, okay, I can just click on this link and I'll see the code level changes that happened that triggered this. Once the chart has been updated, the reference to the image has been merged into the chart, we're going to automatically have a process to roll it out to our staging environment. But before it gets to staging, there's first a clean install from zero. We bring it up completely from scratch to ensure that everything is working in isolation. And we run some smoke tests and see, like, are all the endpoints working? And if the endpoints are working in the dummy environment that we just rolled out, then we're going to tear that down again and roll it out to the long-running environment that is our staging environment that runs with testnet Bitcoin. And the result of that process is going to be another pull request. So the previous pull request was about upgrading the image definition or reference in the chart. This pull request is about upgrading the chart in the production environment. So every new image brings a new version of the chart, and that has to be propagated now. A few details of why are we doing this separation between the automation system and using GitHub and pull requests to do this triggers. Well, it enables us it enables us to have a better security standards where you can use the GitHub protected branch feature to only merge when there are a certain number of developers have approved this. So by having the merge of the pull request be the trigger, we can segregate the access to the automation system, which has potentially credentials to the environments, from the triggering mechanism. So developers can autonomously roll out the changes to all the environments via approving these pull requests, and there's no risk of them getting access to the hot wallet, for example, because it's a segregated system that actually does the rollout. So another thing that typically happens before we roll out to production would be to take a look at our tracing system. We're using OpenTelemetry to have distributed tracing across all the services. This is just to improve the operability of the system, basically. And in this case, we're looking at the Honeycomb UI, Honeycomb IO UI. This is what a trace would look like. So if you want to ship a new feature, you're a developer, and you get to the pull request that would ship to production, you can test your new feature or whatever and say, aha, okay, here's a trace, it's working, it's good. You can put a link to the trace in the ticket, so and approve it, and the next developer that also needs to approve can be like, oh yeah, okay, I can see it's working. And yeah, that's just a really good way to get runtime insights, basically insights to your production runtime with a open tracing. All right. And finally, when that is merged, we have our production rollout, and this basically will scale to a number of production systems. It could be that we have either parallel or an additional gate to roll out to additional clients. But for now, this is the Bitcoin Beach production system that gets affected. All right, so that was a little bit of an overview of some use cases and a little bit of how we operate and some upcoming features. So, as I've been mentioning, it's meant to be reproduced, and we can bring up additional environments within a day, basically, for communities or clients that want to test it out and work with us. They get their own API, a complete copy of this whole stack that I've been talking about. We've been doing a lot of work in redesigning our API. The existing API that's powering the Bitcoin Beach wallet was developed, let's say, under time pressure. Like, you know, you want to ship fast and prove that the what you're building actually has value and gets traction, and wasn't necessarily optimized for in a long-term, with a long-term perspective. So we've spent time redesigning it in a way that we feel like, hey, third parties that want to integrate with us will be able to support that without making any breaking changes. It's basically implemented. We're in the process of now switching out the usage of the old API for the new API in our mobile wallet, so the front end, and that'll be complete, yeah, fairly soon, a couple weeks maybe, and that should be the give us the ability to vet, like, okay, is this really what we want to go with, and is it stabilized? And you'll hear an announcement about it fairly soon. If you do want to try things out and integrate with the API, then already you use the new one. There might still be breaking changes, but it's, like I say, already fairly stable. All right, support for USD storage and transactions. This is now thinking a little bit further, maybe next quarter. We want to have wallets that are able to store their value in USD terms and not just in Satoshi terms, and also send transactions based on USD values. Like if you're in the UI now, you can already give in a dollar amount that you want to send, but it will do the conversion and send the Satoshi amount, and the receiver, if the receiver is in Bitcoin Beach, will basically have a fluctuating value of what they receive because it will be Satoshi. So we want to have the ability to store values stably denominated in USD. And in general, a very big topic that we'll be focusing on a lot in the near future will be better support for merchant accounts. That's a big pain point that we've had for the merchants at Bitcoin Beach. I mean, it's working, but it can be a lot better for sure. Yeah, so that's a little bit of the upcoming stuff. And here's the link to our awesome Galloy page, which is like an entry point if you want to find any of the other repositories. There are, 5, 6, 7, I don't know, maybe 10 repositories that make up all of the code that you need to run the stack. Awesome Galloy is a place where you can go to find them all in the context. Here's the API docs, and we are hiring. So join us. We're across the whole stack: designer, front end, back end, infrastructure, automation work. Let us know. And that's all I've got. Is there time for a few questions? Or, yeah. Did we have a question?
Hi, thank you for the presentation. Is there a reason you went for L&D, or what was in the process of choosing the implementations that you would go with?
So I wasn't involved in the decision, so I can only speculate, but I would say L&D has a very good track record of being able to operate and have support very large nodes, and it's very well documented. I think for business use cases, L&D is the natural choice.
Regarding the dollar storage, did you think of talking with the government or the Chivo people to interoperate with them and have like an API with their fund to convert to the dollars that they have?
Right, so there are a number of ways that we're investigating how we want to support that use case. To your question in particular, using or integrating Chivo for the dollar-based value is not going to be one of the options that we investigate. I don't think, no.
Hi, hopefully this is not a silly question, but how do you handle the multisig from the cold wallet to the hot wallet? Did you guys automate that process with a different device, or is there somebody clicking? Probably not, but how does that work?
Right, so the rebalance in the other direction from cold wallet to hot wallet has to be a manual process because the keys are offline, right? It's hardware wallets owned by the custodians of the multisig that have to go in and sign the transaction. This is inherently not automatable because it is a cold wallet.
So do you guys have a limit of how many times you have to do that? Like maybe when it's 1 Bitcoin, 2 Bitcoin, or?
I don't quite understand.
What's the amount that you decide to recharge the hot wallet? Like how much does it have to have always?
Oh, what is the minimum amount in the hot wallet?
Yeah.
That yeah, that's a case-by-case decision. You know, the operational side in terms of managing liquidity, both from the Lightning channels as well as like rebalancing, is something that we still need to spend some time in improving and optimizing and automating. For now, it's more like, okay, how are the payment flows going, and how, you know, how much do we need? And yeah, we don't have a rule for that.
We have time for one more question.
I saw that you were using MongoDB, which is a NoSQL. How do you send the information from the ledger to MongoSQL, or like, you know, how does the blockchain information goes into the NoSQL database?
We're not storing or indexing the blockchain information. There might be some confusion when I had on the slides updating the ledger. This was not the blockchain ledger. This is our internal ledger that is persisted in MongoDB, but it's a dedicated data structure that has this. Yeah, does that make sense? All right. Thank you very much.
Okay, before we bring up the next speaker, I'd just like to say thank you so much to the organizers for putting on an amazing conference. So please give the organizers a round of applause. Great. So next up is El Sirian from Blockstack.